Okay, so the first thing that we want to construct with this information is a histogram. And let's define what a histogram is first. So a histogram is a graph that displays the data using vertical bars and of various heights that represent the frequency of the class. So it's a graph that displays the data using vertical bars of heights that represent the frequency of the classes. All right, so on a histogram, we have an x-axis and a y-axis because this is a graph. So histogram the x-axis is equal to the class boundaries, and these are equally spaced, of course, across the x-axis. Whoops. And then the y-axis is equal to the frequency of the classes. So let's look at an example of this. So first, let me grab this table. I'm going to grab this table and bring it down. Whoa, there we go. And bring it down here so we can look at this stuff and create a graph. All right, so here we go. We're going to do an x-axis. Oh, wrong pen. Oh, that was a y-axis, and here's an x-axis. Okay, so the y-axis is frequency, and the x-axis is class boundaries. And these class boundaries are measured in miles per hour, because that's what our measurements are. All right, so the first thing that we find out is the first class boundary we have is 17.5. So I'm going to put it on here, 17.5. Now notice what happens here is I have this gap between 17.5 and the 0 where the y and x-axis intersect. That's a big gap. So I'm going to put this squiggle line that says, well, if this will let me do it, the squiggle line that basically says what we've done is we scrunched up the x-axis, and I don't see this part of the x-axis that's scrunched up. This part's gone, but I start looking at the x-axis here at 17.5. All right, and then the next boundary value that I have is the next lowest boundary value, which is 20.5. And then the next one, and I'm putting these equally spaced, 23.5. 26.5, 29.5, and then the last boundary is at 32.5. All right, so those are all our boundary values. Now our frequencies, if we look up here at the top, our frequencies are going from 1 to 14. So I have to have a spacing here that allows me to go to 1 to 14. So let's go 2, 4, 6, 8, 10, 12, 14. And that'll allow me to get these frequencies on there. So the first thing that we want to do is our first class. It goes from 17.5 to 20.5, and it has a frequency of 1. So we want to make a bar graph that has a frequency of 1. And so that's the height of that bar is a height of 1. Now from 20.5 to 23.5, we have a frequency of 9. So in that range, we want to go all the way up to 9. Let me fix that because it comes over too much. All right, so there's a bar from 20.5 to 23.5, whose height is 9. And then the next one, 23.5 to 26.5, we want to go all the way up to 14. Okay. There we go. And then 26 to 29, we're up to 5. That's going to be right along, right along here. And then from 29 to 32.5, we're at 1 again. So that's right about halfway in between. We go 1. So that's our histogram. Now, one thing that we want to look at with the histogram is the shape of it. And so if we go to page 64, I have this down here. Let's pull this up. And look at this graph. Okay, so these are the different shapes of histograms that we can categorize. And they're a little hard to read, but you're going to look on page 64 of your book, and this has all these shapes. So this one is bell-shaped. This one is uniform. This is J-shaped. This is reverse J-shaped. This next one is right skewed. This is left skewed. This is bimodal. And this is U-shaped. Okay, so we have these 8 different shapes that we're looking at, and what I want to do is compare my histogram with these 8 shapes and define what shape it is. And that's when it says describe the shape of the histogram or describe the histogram. And we usually only describe histograms. So if we look at ours, here's ours, and we compare it with theirs, I think it's pretty close to bell-shaped. It's not perfect, neither is the bell-shaped one. There's no real tails, so it's not a J-shape or a reverse J, or a right skewed or a left skewed, and it doesn't look like a bimodal or a U-shape. So I'm going to say this is bell-shaped. All right, so that's how we describe the distribution of the data or describe the histogram. It's bell-shaped, and that's always comparing it to this table on page 64 in our book. All right, so I'm going to stop there, and we're going to do frequency polygons and ogives next.